Iris and I are very honored to be invited here. We're so sorry that we can't be here in person. We'd love to be part of the activities that are going on, see our friends, and be able to give the talk directly to you in person. Unfortunately, we're not able to do so. I would like to express our gratitude to President Fox and the Mexican government authorities for hosting this event and making it possible. It's an important event, and it's going to do a lot to help move the world forward into a hydrogen and a fuel cell and a solar cell future. I want to thank ANIS and FERCO and the World Bank for sponsoring this. I think that it shows a great sense of what the importance of the problems of energy today, and I appreciate the work that's going into it by all my colleagues and collaborators who are in the audience. For all of you are my collaborators, and thank you again. Now, the first slide is to not to go down memory lane, but to show how long it sometimes takes if you want to change the world. And in a storefront, Iris and I got together to start in January 1960, Energy Conversion Devices. And if you notice from that slide, beside that I have black hair, and of course Iris is as beautiful as ever, you'll see that it says sun up there, and that it says radicals. And you'll see hydrogen molecules, and you'll see that it's broken up to protons, and you'll see that has to be storage, and that there has to be another electrode. And in other words, I'm making a hydrogen loop to say this is what we have to accomplish scientifically and socially and for our society if we're going to take and change the way energy is used in the world. In 1960, there wasn't much concern about that. But since we were to address and solve serious societal problems, that was our aim, we thought that energy and information were the twin pillars of our global economy. And information, as I've now proved through the years, is encoded energy. They're one and the same. Now, in case you think that that was an exercise of drawing on a true blackboard, then you'll see that if you look close enough, there's a hydrogen small tank, and I'm doing experiments that have to do with catalysis and storage. It's truly a desktop experiment. And the reason it's a desktop experiment, that was practically all we had in the laboratory. Now, let's see what we did with that loop that I drawn before. All the things that you see are actualities that we make or participate in and enable in that loop. And we start with the sun. Well, what's the sun? Well, hydrogen was born in the Big Bang. It had protons, electrons, photons, neutrons, all born in the Big Bang, the beginning of our universe. You can't go further than that. And almost all matter that we know has protons as their constituency, as hydrogen. Therefore, what happened after the Big Bang, what happened to the hydrogen? It was clouds of hydrogen, and it condensed into stars and galaxies. And our star, the sun, is burning hydrogen. Actually, it's fusion of hydrogen. And by burning hydrogen as a fuel, it puts out photons which impinge upon our photovoltaics and makes electricity. So in a sense, the hydrogen economy started with photovoltaics. And from that loop that you see there, if you generate electricity, this has to be the system. We have our batteries. Our batteries, 1 billion hydride batteries with hydrogen ions going back and forth. That's what, again, was a great initiator of the hydrogen economy. Because without knowing it, people were using what was prosaic, which was batteries, but started using, and 1,250,000,000 of them for consumer products batteries were made last year, nickel metal hydride, Ovarnic nickel metal hydride. So that started use of hydrogen now for storage. And then if you have, of course, if you have storage, you have to have, you want to use it. And fuel cells are also another part of the generation of electricity, the generation just like solar energy is. And therefore, fuel cells are very important because they have great opportunities for all of us. But beside the automobiles that you see now, you know that there are, some of you may even be driving some. The Toyota Prius is a hybrid, and it burns hydrogen. What are the problems we face in the world? The problems we face in the world in energy is that the fossil fuels produce pollution, climate change gases, and really wars over oil. We might as well say it's because basically that is the reason, for example, that all countries are interested in other countries that have oil. Now, everybody would like to burn hydrogen in a fuel cell, and yet many claims were made about how soon fuel cells would be used. But except for prototypes that have been used, it has not taken place, and I'll explain why in a moment. Actually, we have been able to prove by taking a Prius and changing it from a gasoline hybrid to a hydrogen hybrid, we've been able to meet the same expectations that was certainly not thought possible as one could utilize with a gas engine without any pollution practically at all. No CO2, no climate change gases, which is one of the great problems that the world faces or should face. And if you have an engine, you must be able to have the fuel, and that fuel, in our sense, is not only the nickel metal hydride batteries that have enabled hybrids of all sorts to come out, whether it's Honda or whether it's Toyota, or whether it's the big three. Our Ovarnic nickel metal hydride batteries enabled the hybrid industry as it did the electric car. And when we speak about hydrogen, whether it's for a fuel cell or for whatever purposes, you really want to be able to use the photovoltaics that we have. That is a triple junction where there's 3 different band gaps, which take you into itself all of the parts of the spectrum of the sun that's available to us. And we generate electricity. That's why it's very good. First of all, it gives us higher voltage and currents, of course, but it gives us the opportunity to break up water inherently. And when you break up water, you now have the ultimate fuel, hydrogen, without depending upon the other sources. Hydrogen is the ultimate fuel, but if you use it as high-pressure gas, it has very limited use. I know of no company that will make a production vehicle using pressurized gas. Now, if you don't have, you can have hydrogen, and hydrogen's been around since the beginning of the universe. What do you need to make it realistic now for our world and global society? And what you really need is, first of all, we're realistic. And we'll take hydrogen from whatever source, from fossil fuels. For example, oil companies have water and also hydrogen as byproducts. We'll take it from anywhere. However, the best way is, if you see on the left side of that parking structure, the best way is to have it as photovoltaics breaking up water. Now, you have to have an infrastructure, and all of you here, the infrastructure that I'm talking about is whether you use an internal combustion engine to burn hydrogen or whether you use fuel cells. You have to have the same infrastructure that I'm showing you here that we have enabled and that we've made possible. So it's not that you need a new one for this, it's the same infrastructure. And what you need to do is to have hydrogen in a solid. This is 7% hydrogen in a solid. I won't discuss it much further, except to say that this was 250 degrees C necessary to bring out the hydrogen, but you could go many, many miles capable of reaching automotive commercial use if you wanted to use it that way. The fact of the matter is that when you put hydrogen in a solid, it's the lowest free energy. It's completely safe. You can carry it around anywhere. It's not dangerous. In fact, Bob Stempel, who was one of the world's best engineers and great automotive expert, and our chairman, who was formerly head of the General Motors Company, makes the statement very clear-cut. Gasoline is far more dangerous than hydrogen. But once you put it in a solid, it's not enough. There are two major problems that's held back putting hydrogen in a solid. One of them has been kinetics. You put it in, and sometimes it takes a while to do that, but you put enough in, you have a hard time, sometimes days, sometimes weeks, of getting it out. The problem of kinetics is very important. This solid here, solid hydrogen we call it, our Ovarnic solid hydrogen, is once you have this, you can put it in a minute and a half, and you can take it out as you wish. So the kinetic problem is solved. And then, of course, you have to have lifetime. And we stopped testing this when we reached the equivalent of 650,000 miles. I think that that's pretty good for automobiles. We stopped testing. It didn't fail. Therefore, hydrogen in a solid gives you a tremendous advantage in permitting you to solve the infrastructure problem, which various vested interests have said is going to cost trillions of dollars and is unrealistic, and it'll be 50 years from now. Why? Because when you have a solid, you can carry it around. You can not only do it if you like in a pipeline, but you can put it in an ordinary truck. You can put it in an ordinary train. You can put it in an ordinary boat. You can take it anywhere you want. There's no question about its transportation. And then, in terms of its use, you can have a gas station. You don't need to put the tank under the underground because there's no spillage or leakage here. Therefore, you could place it anywhere. You could use photovoltaics on the roof of your gas station. And very importantly, if you'll notice that we have also Ovarnic metal hydride pressure regulation and purification and dispensers so that the whole system is a hydride system. This permits me to show you what a hydrogen in a solid looks like. When we utilize it, it is usually in the form of a powder. And that is what's necessary to accomplish, to solve the hydrogen loop, to make hydrogen as a system realistically. So we call it the Ovarnic metal hydride technology. Without this technology, you would not be able to have the Ovarnic regenerative fuel cell. As you look at that, you can see that we have various ways of storing hydrogen, having stations of, that's a miniature gas station actually on the left side. I mentioned our consumer batteries. Our automotive batteries work as our hydrides, our nickel metal hydrides. The way that you put them in an automobile and a prototype, then the ones we're doing now will be under the car, but are simple. And we made a Prius into an internal combustion car, as I mentioned, and it performed just as good. In fact, an automotive executive said, several said, this is completely transparent to what we're driving, and it is very impressive. It's very important because it's running on hydrogen, and it is the transition, or maybe it will continue, but it's the transition to the fuel cell. On the right side, you'll see a bus. That bus is pure electric. We have others that can be hybrid, that are hybrid. But in any case, you'll notice that we have plug and play for our batteries, which means you just put them in, plug them in for the automotive manufacturer, and they work. We would, of course, as part of the loop, would like to have our fuel cells run in a non-fossil way. In other words, instead of plugging into the Earth's resources that are dwindling, plug it into the universe, the first particles of the universe. And in this case, you need to have, remember I said we not only invent the materials, we invent the products, we invent the production technology. This is to give you an indication of the size, that machine for photovoltaics, which is capable of making 30 megawatts of electricity a year, is capable of 9 miles and 6 tons in a single 2.5 or 3 day in between range, and being able to have, without continuously making a triple junction, because the film that is deposited on there, on the products that you see, those are the rolls we put in the machine. That film is less than 0.5 micron thick. In fact, while we make shingles and other roofs, which I'll show you, here we're talking about something which the same film that's on this ultralight material is the same film that you see in the slide. Now, you'll say, well, are you not dwelling too much about solar? Isn't that a part of the other programs that we're having here? Since it's a system, what I like about this picture is not only is it beautiful, it's showing you the various installations and how aesthetically pleasing it is over big, heavy, unbreakable crystals. And by the way, we have put bullet holes through our materials, and all you lose is the size of the hole. They're very robust. Is that you take the energy from these roofs, and from the roofs of houses, you take such energy from the sun and you break apart water. And at the bottom, you'll see that we are also helping run an oil field because it's cheaper to have the sunlight to provide the energy. And because now we're getting to fuel cells, well, that car, that automobile, is a Toyota that is an all-hydrogen hybrid. The one that I said burns internal combustion engines, uses our batteries, and at the same time at the same time has an internal combustion engine that burns hydrogen and has remarkable achievement of equaling, if not being a little better than a ordinary gas engine hybrid, and as good as the fuel cells that we've seen. What's so important about that is not the cars that we're showing, but if you look at that tent, you'll see there's photovoltaics. Our photovoltaics are part of that. You just accept it because it's beautiful and it's prosaic looking, and what's different about it? It looks like a tent. But however, that's at a Toyota exhibit. They filled the fuel cell car they had and were demonstrating from that roof. Now we come to fuel cells because I wanted to say that we had to have a perspective of where fuel cells come in and why they haven't lived up yet to the expectations, because there's been a great ignoring of the problems, and there has been too much claims without addressing the problems. And we here in industry know that what one must do is to make things, and it's better to make than talk about them. I would prefer to have you see our plant than hear me talking, our plants than hear me talking. What's wrong? Why hasn't PM fuel cells made it? Because the cost is too high by orders of magnitude, an order of magnitude. It needs noble metal catalysts and costly membranes. Remember that membranes are ionic conductors. In this case, there's even some moisture needed for that process. The durability needs 5 times the improvement because of the membrane degradation issues. It needs a separate battery for regenerative braking. It needs a battery for cold start. And it has overheating problems in hot conditions. And I should say also it has a problem that's an engineering problem that I'm sure will be taken care of, takes up space, and that is radiators. So a basic new approach is needed. Let's see what such an approach is. An Ovarnic regenerative fuel cell, you might have heard of it. It's a fundamental new approach to fuel cells. It uses no noble metals, which you shouldn't be used because it makes the fuel cell very, very expensive. And also, it doesn't use the membranes that are very expensive either. The only fuel cell that can be run backwards and store regenerative energy in the fuel stack itself. It has unique energy storage functionality, and it uses low-cost materials. It can actually run without being fed hydrogen because of the storage capability of our electrode. And this is the electrode. And it's a simple picture. Looks like any other picture probably of a fuel cell. The differences are that we tried to solve the problems of PEM, and I think we achieved that. But our approach, by the way, can be used across the board for any kind of a fuel cell. It stores hydrogen in a stack. It's rechargeable chemically and or electrically. It has our positive electrode, or that is our oxygen electrode, is also made to have unusual characteristics. And in fact, in one of its coming generations, you can even have higher voltages than you would expect from a fuel cell. And it is proprietary. And as I said, it can be applied across the board. But this shows what we do, what the innards really look like from a physical and chemical point of view. Now, what's an advantage then of an Ovarnic fuel cell? It's low-cost materials, no membrane durability issue and cost issue, accepts regenerative braking energy. Very important. If you step on a brake in an ordinary car, you can lose as high as 30% of your energy to heat. Here, you use it so that you can store the hydrogen and have it for regenerative purposes. And it's instant start. This is very important. And we operate at below freezing temperatures and have great heat rejection and superior efficiency. And we can operate without hydrogen input. As much operation as sort of things that you'd want to design into the fuel cell. If you look at our practical design approach, it is very manufacturable. Most importantly, it is scalable. That means you can make it from the little to the big. It's modular, and our fuel cell will be much cheaper than the conventional approach. And why? Why? Rather than talk about it, you can see where the inherent high material cost is of PEM and where we can reduce and have reduced. The catalyst comes down dramatically, the electrolyte dramatically, the interconnects very, very importantly, and the hardware greatly. This comes from our economic study of our costs and the competitive costs. And you can see that this is what will allow fuel cells to have a much earlier introduction and perhaps save the honor for all of us in the fuel cell business, because there's been so many claims made in the past. This is a small fuel cell just to show what it is. I don't think I need to tell the group here what markets there are. Frank Ingersoll-Lee, our Executive Vice President of the Ovarnic Regenerative Fuel Cell Company, is in the audience. He'll be glad to speak more to you, any of you, and we'll be glad to answer questions. But you can see a fuel cell is a very universal generator, and it needs everything that I've described before. It needs the infrastructure that we provide, and it needs all the things that I've described in my talk. Now, I don't think we have to dwell on this. The problems were swept under the rug. And as inventors and as manufacturers, we shouldn't do that. But most importantly, for those of you in Mexico and in the developing world, as well as sometimes I wonder about the United States as a developing country, I hope it's developing, is that we must build new industries to provide high-level jobs that feed back in our education system so we can provide jobs, because the old industries, and the world is replete with famous names that are no longer around, if they do not change, then we all suffer from it. And I want you to take into consideration the most important thing that I can think of, and that is the 2 billion people without electricity. We are talking about rural electrification. If it wasn't for rural electrification in the United States in 1934, we would still be a very backward country. I've shown this slide all over the world because every time I show it, I get chills. And we all need to have encouragement. We all need to feel that we're doing something, that we actually are changing the world. This young lady, please note, she's barefooted. She's going up a path that a donkey can't go up. She's carrying photovoltaic packs on her back, the future on her back, and the future in front of her. Because that child will go to school because of the rural electrification. We electrify schools, telephones, television for education, lights. The next has to be small industries. But that's why all of us should take to heart that we're not talking about just another commercial product. We're talking about making the world more civilized and a better place to live in. and doing something about the problems of war and peace and jobs. And at the same time, getting the joy of doing advancing science and advancing technology. I wish I could be with you. I hope that this being an experimentalist, that this works, because I hope that you know from the bottom of our hearts, we would love to be with you. And our friends in the audience that we can't see, we just want to say we appreciate being invited. It's an honor, and we look forward to the future with all of you, our colleagues and our collaborators, working together in our various ways. Thank you.